In this lesson, we will start the trigonometry unit by talking about special triangles and special angles. So from the special triangles, we will get the special angles, and we will ask ourselves why these angles are so special. So let's look at the first triangle here. We have first of all, it's a right triangle, and not only is it a right triangle, it's a right isosceles triangle. So if both the legs of the right triangle have a length 1, then you can use the Pythagorean theorem and show yourself that the hypotenuse will be equal to root 2. And 45 degrees, that makes sense because the two acute angles of the right triangle must have a sum of 90 degrees, and since it's isosceles, both must be equal to 45 degrees. So from grade 10, we learned the definitions of the primary trig ratios. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So sine 45 degrees, doesn't matter which 45 degree angle you look at, but you'll get opposite over hypotenuse, which is 1 over root 2. So cosine 45 degrees will be adjacent over hypotenuse, so 1 over root, hey, it's also 1 over root 2. And tan 45 degrees is equal to 1. Opposite over adjacent, 1 over 1 is 1. Now, nothing is wrong with 1 over root 2. Okay, 1 over root 2 is perfectly fine. But back in the day, people did not have calculators. And trying to find the approximate value of 1 over root 2 is very, very tricky because we are dividing by root 2. And you know what? Root 2 is an irrational number, so it's very hard to divide by root 2. So what people did, or what people really preferred, is that the denominator to be a rational number. So this process of changing 1 over root 2 is called rationalizing the denominator. So I'll write it out over here, 1 over root 2. And we're going to multiply it by, well, how do you make the denominator rational? You multiply the denominator by root 2. But you can't just multiply the denominator by root 2. So what we're going to do is multiply the numerator and denominator by root 2, which means essentially you're multiplying by 1, which is fine because multiplying by 1 doesn't change anything. So let's simplify this. So the numerator is now becoming root 2 and the denominator is equal to 2. So 1 over root 2 is exactly the same as root 2 over 2. And which one do we prefer? We prefer root 2 over 2 because the denominator is rational. So just to show ourselves, so we have 1 divided by root 2 and root 2 divided by 2. Numerically, they're exactly the same. But if I didn't have a calculator and I wanted to find out the approximate value, then root 2 over 2 is a lot easier for me to approximate the value. All right. So that's our first special triangle, and now we're going to look at the second special triangle. So the special triangle is actually, it begins as an equilateral triangle. It begins as an equilateral triangle. And then we divide the equilateral triangle into two right triangles. Basically, we draw the altitude from, well, we chose vertex A, but it really doesn't matter. So you start with an equilateral triangle with side lengths of 2. You could pick any side length, but I think 2 will make our lives easiest. And then you split it in half using the altitude, or you can even argue this is the median because it's equilateral. So the median and the altitude are the same line segment. So if CB is 2 units because it's equilateral, then DB must be 1 unit. Now what about AD? How do you solve for AD? Well, if you have AB and DB, you have 2 of the 3 sides for a right triangle. You can solve for the third side, AD, very easily using the Pythagorean theorem. And you will get root 3. Now here, why does it make sense it's a 60-degree angle here? Well, because it's an equilateral triangle. Angle ABC must be 60 degrees because all the interior angles of an equilateral triangle are 60 degrees. And if this acute angle here is 60 degrees, then the other acute angle must be 30 degrees because the two angles are complementary. All right, so now what are the special angles here? 30 degrees, and 60 degrees. So using the triangle ADB, you can find out what sine 30 degrees, cos 30, tan 30, and then sine 60, cos 60, tan 60. So give yourself a minute, try to use the triangle ADB and find out the ratios. Okay, so sine 30 is half, cos 30, root 3 over 2, tan 30 is going to be 1 over root 3. But wait a minute, we are going to rationalize the denominator, right? So if you write down 1 over root 3 over here, you can multiply by root 3 over root 3, which becomes root 3 over 3. Sine 60 is root 3 over 2, cos 60 is 1/2, and tan 60 is root 3, because it's root 3 over 1, which simplifies to root 3. So why are these angles, 30 degrees, 45 degrees, and 60 degrees, why are they called special angles? Well, they're special because they're I think another way of saying is they're very friendly to work with. Very, very friendly to work with. You can find the exact value very, very quickly if the angle is either 30 degrees, 45 degrees, or 60 degrees. So that's why we call them special angles. Can you find the exact value of, let's say, 29 degrees? And the answer is yes, but it's a lot of work. Okay, it's very different from what we just did. So I would say you can find the exact value of, let's say, 22 degrees. You can find the exact value of any angle you wish, but it's a tremendous amount of work. Okay, so I'm gonna fill in the table, and this is what you should refer to in order to help you memorize it. Okay, and I'll give you some little tips to help you memorize the ratios of the special angles. So sine 30 degrees is half. So the way I'm gonna fill it out is to help you memorize it. So if sine 30 degrees is half, I know that cos 60 degrees is half. I'll explain how I know in a second, but if sine 30 degrees is half, then I know that cos 60 degrees must be half. If I know that sine 60 degrees is root 3 over 2, then cos 30 degrees must be root 3 over 2. And if I know that sine 45 degrees is root 2 over 2, then I know that cosine of 45 degrees is also root 2 over 2. Now, how did I know that? Well, I'm going to play with my calculator to show you how I know. So normally I would ask my students to give me a random angle, random acute angle. So I'm going to try to be as random as possible. I'm going to say 17 degrees. That seems like a very weird number to work with, but sine 17 degrees. Okay, so I'm going to work out on my calculator. Sine of 17 degrees is equal to cosine of 73 degrees. Okay, let me check. Sine of 17, okay, and cos of 73. Hey, what do you know? And then you can pick some other angles you want. So we're going to pick some weird ones. I don't know, 63. And another one, I'm going to do something weird, 5.74 degrees. Okay, so what is equivalent to sine of 63 degrees? And that's going to be 27. Let's do a quick check. Sine of 63, cos of 20. Hey, perfect. Now, whoa, what about 5.74? 5.74. Let's write down cosine of 84.26. Let's check it out. So sine of 5.74. No way, is it gonna work? Of course it's gonna work. So what's the pattern here? Hopefully you can see a relationship between 17 and 73 degrees, and between 63 and 27 degrees, and between 5.74 and 84.26. What is the relationship? The angles are complementary. They add up to 90 degrees. So when I think of cosine I think of the meaning of cosine. It's sine of the complementary angle. Okay, cosine is defined as, yes, it's adjacent over hypotenuse, but you can also think of it as sine of the complementary angle. So what's cosine 73? Ask yourself what's a complementary angle, which is 17 degrees. So sine of 17 is cosine of 73. So that's how I know when I'm looking at this table of special angles and the ratios for each of these special angles, you know what? You have 30 degrees and 60 degrees. And 30 degrees and 60 degrees are complementary. And what's complementary to 45 degrees? 45 degrees. So it makes perfect sense that sine 45 degrees is equal to cosine 45 degrees. It makes perfect sense that sine 30 degrees equals cosine 60 degrees. And lastly, it makes perfect sense that sine 60 degrees is equal to cosine 30 degrees. So hopefully that helps with the memorization. But like I said, if you do all the homework, it's going to come to you very, very quickly. All right, last one, tan 30 degrees. Tan 30 degrees is root 3 over 3. Tan 45 degrees is 1. Most students find this very friendly. Tan 45 degrees is one of the first ones that students memorize. And lastly, we have tan 60 degrees is just root 3. So if you forget tan 30 degrees, you can actually find tan 30 degrees by knowing what sine 30 degrees and cos 30 degrees is. Later on in the unit, you'll learn that you can actually take sine 30 and divide it by cos 30 to get tan 30. You can take sine 45 and divide it by cosine 45 to get tan 45. And lastly, sine 60 degrees divided by cos 60 degrees to get tan 60 degrees. But you know what? If all else fails, and if you really forget any of these ratios, what you can do is just draw your special triangles and come up with them. Okay? So try to memorize them tonight. It will be very, very, very helpful. If not this year, definitely next year.